Okay guys, we continue. So 5.5, now we will look at a few definitions. Okay, so let's let u to be some vector with components u1, u2, u3, and with that given component form, and v be a vector with those components and in that component form. Okay, and let's also let okay, sorry for that. Okay, so let these guys be vectors, and so let u and v be vectors, and k be a scalar quantity. Okay, so remember, difference between vector quantities and scalar quantities. Remember, so scalar only has magnitude. Okay, so we can define two rules. One is the addition property, so the vector u plus the vector v is equal to, we just add the components. So we can just add the components, u1 plus v1, u2 plus v2, u3 plus v3. Okay, so we just add the components, and then we can also have scalar multiplication. So usually that's what we have. So the addition and the scalar multiplication. Okay, close. So addition of two vectors, you get another vector. Multiplication by scalar, you get another vector. So k times u, you get k times u1, k times u2, and k times u3. Okay, and then okay, 5.6. Okay, vector operations. So just a few rules on vector operations. Okay, I'll let you underline to show that they're vectors. So I think I didn't underline u. I also didn't underline v. So always don't forget that you can use underlines to show that you're talking about vectors. So let u, v, and w be vectors. Be vectors at the same time, and let also a and b be scalars. So we have got u, v, and w are vectors. A and b are scalar quantities. Then we will have the following 9 properties. So the first property is that it's a commutative property. So whether if you add u plus v, it's the same as v plus u. So that's a commutative property. So it doesn't matter with the order of addition. Okay. Then also any vector plus the zero vector, you get that same vector. Okay, 0 as a scalar multiplied by any vector, you get the zero vector. Okay, so some scalar quantity multiplied by a vector multiplied by scalar quantity. There's that associative property. So you can begin by multiplying the scalar quantity, the scalars first, then multiply the vector. Okay, so then you can also begin, if you have an addition of two vectors, you can always, addition of two scalars multiplying a vector, you can always apply distributive law. Okay, then we can also have associative law on vectors. So it doesn't matter how you add three vectors, whichever order you start with, you still get the same vector. Okay, number 7, we add a vector plus negative of that vector, you get 0, the 8th. So if we have some scalar quantity 1 multiplied by that vector, you get the same vector. And then the last property is where if you have a scalar quantity, okay, this is scalar quantity a, and then you multiply it by vector u plus the vector v. You can always distribute the vectors as follows. So okay, so that's what we have in terms of the various different types of vector operations which we can come across. Okay. Okay, so we continue. So we now I'm giving you guys a homework or an exercise which you add on to the problem sheets that you have. So this is for you guys to solve and just try out these questions. Okay, so let U be a vector with the following. Okay, underline it with the components -1, 3, and 1. V be a vector with components 4, 7, and 0. Okay, so the question is find the component form. Find the components of the following vectors. Okay, so 2 times u plus 3 times v, that would be a vector. What are its components? Also u plus okay, u minus v, that will also be another vector. So you can find out what the components are. Okay, and also that also be a vector, half u of that, so that will be a vector. Okay, that's the end, you guys. See you in the next segment. I will be looking at other concept of vectors. Thank you.